Hey everybody, it's Keith with Bob CNC. Welcome to Shop Talk, and as always, I'm always here with Bob.
And I'm always here with Keith.
I wouldn't have anything to say if you weren't here. Of course, I don't have much to say when you are here. I just kind of sit and listen.
You say a lot for not having much to say.
Thank you, Bob.
Just saying.
All right, well then I'm just going to be quiet and let you talk about...
This won't work very well.
When you're shopping for a CNC, we're doing this series on the anatomy of the CNC. And one of the things that you're going to hear bandied about by different manufacturers is their drive system. And so we just wanted to go over the different types there are so that you'd have a little bit of background as you're reading. You could understand what you're looking at,
right.
Advantages, disadvantages. And so Bob, what is, the most basic is going to be what, like a threaded rod?
Yeah, so back in the day, my very first CNC, I'm talking about building your own here. A threaded rod will work. It will take rotational, which is going to be from your motors, and turn it into a linear motion, right? It's not very fast. There's going to be some backlash, and there's ways that you can deal with that. But if you're on the cheap trying to build you a CNC that with no money, yeah, threaded rod's a good system. The next one up would probably be the belt drive. Especially with the 3D printers out there today, the GT2 belts, I think you can go buy 10 meters of it on Amazon or eBay for almost nothing. But it makes a really good drive system. You can buy some pulleys. It's really fast, and as long as your loads are light, you're going to be fine there.
The greatest downside, maybe that's it. What the greatest downside
for a belt side? Well,
yeah.
I think your belt stretch, right? If you take too much load, you're not going to be able to have the accuracy that you need because you're going to have belt stretch, especially if you have a large machine. Now, there's ways around that. You could have a wider belt or a thicker belt, but in the end, everything will stretch. Even steel if you pull on it hard enough. But so you'll buy them steel reinforced, or they'll have fiber in them. It don't matter. If it gets too large, it'll stretch. However, if your loads are light, your machine is small, the belt drive systems will work. Our Evolution series and our Revolution series both have a belt system, and it works really well for that. So the next one that you'll see is maybe an Acme drive, and for guys that have been in this for a long time building their own machines, like went from the threaded rod, and you're like, well, this is way too slow, and I can't get the accuracy that I need because of the backlash. So we went to Acme rods, and they were expensive, but you could get 1 start, 2 start, 3 start. But really, in effect, what that meant is I would move further for every time I turned it around, so I could go faster, and we would take a hunk of this rod, and then we would grind or mill and make our own taps so that we can make our own Bell-Everman nuts, right? And it worked well, right? So back in the day, you can find these systems out there now with the Acme screws, right? And a Bell-Everman nut, and there's lots of folks that have come up with anti-backlash methods for those as well. But honestly, the ball screw came along, and with the popularity of CNCs and everything, it's a lot less expensive now. So a ball screw really it's still like an Acme nut thread, but it's actually got the shape of a ball now. And just like the linear bearing that we talked about before, now you have this rotational ball system in there. So you're really rolling contact now. You're not sliding like you would be with a threaded rod or an Acme rod, right, with a nut. So that makes low friction. And you can buy you can buy these ball screws with different preloads or different settings. And so you can buy them where they're a little loose, but they spin really free. Or you can buy them with a preload, so the balls are a little fat, so there's kind of like it's pressing in there. They have no backlash whatsoever. Well, I shouldn't say that because there's always some, right? But it's very little, and of course those are more expensive. So when you go out and you're looking at a ball screw system, maybe one of the things, especially if you're trying to get the best bang for the buck, maybe you need to investigate on what type of ball screw are you giving me? Are you giving me a loose ball screw, which is easier to do, or one that has less tolerance, or are you giving me one that's actually preloaded and is going to give me better results because I really want to make aluminum pieces that they have to be really accurate. So you're gonna look at that. So
Then you got rack and pinion.
rack and pinion, another setup, which is kind of a way of getting around the expense of ball screws. I will say that ball screws, the prices have come down. The problem that you're going to have with ball screw is they're slow, especially if you have a big system. Right. So unless you get into some really specialty ball screws, but then your cost goes through the roof again. So a ball screw system, you have to spin, and if the rail is or the rod is very long, you have to worry about it whipping around, right? Because it's like a guitar string after a bit, right? So somebody said, hey, what about a rack and pinion? So we'll just put a gear down a motor and we'll put it on a rack and a pinion. And that works really well. I mean, now you can go, pretty much as long as you want. The disadvantage for me, other than, they're steel components, and so you have to keep them greased, right? And that's kind of a difficult when you're working with wood, right? The other thing is if you run them too fast, they're typically the pinion is meshed or held in place by a spring, and if you run them too fast, they'll pull themselves out of mesh and you'll lose steps. So if you understand the parameters, it's a really good system. There's one more I'd like to talk about, and that's the Bell-Everman. A guy named Michael Everman invented this. It's called the Bell-Everman servo drive. It actually uses belts. But it doesn't have the problem of belt stretch because you have a static belt that you basically glue to your structure, so it's rigid along there, and then the other side really is a tank track or a way to mesh the belts so that you can have that motion back and forth. It's a fantastically clever system for me, which I think is why I like it. It's inexpensive,
right?
It allows you to move at really fast rates, still gives you really good precision, and it is easy to maintain, so you don't need the lubrication. So that's really, I mean, if I were saying the disadvantage of that is probably the load that you could apply, right? So if you were doing like a mill or something where you're trying to hog through steel or something, probably not Bell-Everman. I think where its fame was the pick and place machines where they're super fast, right, and accurate enough to put the parts where they needed. But it definitely is, in my mind, the best system for your larger machines if you want them to move fast.
I mean, we haven't just investigated these; we have used virtually all these.
Yeah. Oh, I've built several machines with each of these.
Right.
Yeah, our next machine that we're working on will definitely have the Bell-Everman servo drive. We actually have a video on how that works, or you can just type it in your Google and watch the stuff that the Bell-Everman folks put out. It's a pretty clever, pretty cool system. I do not understand why it hasn't taken off so much, because I have not found a huge disadvantage with it. So.
Right. Well, guys, if you've got any questions about drive systems, how they affect the machine or the purchase you want to make, you can get a hold of us at the help desk at bobcnc.com.
Or Shop Talk.
Or Shop Talk.
At bobcnc.com.
Or, oh well.
Info at bobcnc.com.
You can get a hold of us.
Or you can just call us, I suppose.
Well, that's true too. So anyway, till next time, thanks so much.